Hi guys, welcome back to the next lesson in the permutation combination chapter. We are looking at selections and we have seen all the formulas in selections. So now we are moving into a little bit more twisted or the second set of questions on selections, and these are again questions that you should know. The first of them, let's start straight away. The first of them is uh, let's say you are given a situation where you have 16 players in a cricket team. 16 players in a cricket team, and you are trying to find, or you're to select 10, select 11, such that the captain is always selected. So these kind of questions can be referred to as questions which can be described as questions of pre-selection, such that the captain is always selected. So this, as I said, these kind of questions can be described as questions involving pre-selections. That means you're already pre-selecting some selections before you use the NCR. So what happens here is that because you have to select 11, and let's say the 16 players that you have are A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, and you have the captain is always selected, so there must be a captain on this team. So he is pre-selected in the team, so he is fast forwarded and brought in. Now you have to basically, to select the team of 11, you now are in a situation where you have to select 10 from 15 players, and this is a simple straight 15C10, the usage of the NCR directly, and 15C10 is the answer for this question. So this question can also be put into a story. For example, one story you will see that there's a hostel warden who has a hostel with 12 kids living inside it, and he selects 3 people for the committee every week, for the weekly committee. So if he selects 3 people for the weekly committee and selects a different group of 3 every week, then how many weeks can he continue without selecting the same group again? So this would be a straight 12C3 question. But in this question, if I add the condition that he always wants to select his favorite student in the committee, then this becomes a case of the pre-selection, because his favorite student, let's call him A, has to be in the team or has to be in the committee, and then after you remove A and you bring him inside here, out of the 12 kids you only are left with 11 kids, and you have to select 2 more people, although you have to select 3 overall, but 1 is pre-selected. So in this scenario this will become 11C2, and this would be the correct answer to this question. Right, so this is one twist that you will see in selection questions. The other one is where you have what can be described as constraint based selections. What you can describe as constraint based selections. Now what are constraint based selections? Constraint based selections are selections which are based on certain constraints. For example, if I tell you that there are 6 men and 4 women, and you have to select a committee of 3 with at least 1 woman. So there are 2 ways of doing this question. So this is the constraint, that you have at least 1 woman in the group. So there are 2 ways you can do this kind of questions. One way to solve it is that if you define the committees, the different committees you can select, because the committee says that at least one woman should be in the group and there is no constraint on the men, you can have committees with one woman and two men, or two women and one man, or three women and no men. So these are the three kinds of committees you can make in this scenario. And the number, because you have 4 women and you have 6 men, each of these are selections, and will always be an into. The numbers here will be 4C1 into 6C2 plus 4C2 into 6C1 plus 4C3 into 6C0. So whatever that calculation will lead to will be your answer. So I'm leaving that calculation for you. But this is how you can do this. The other way you can do this also is committee with all men. If you subtract this from the total number of committees, total number of committees that you can make minus committees with all men. So first you calculate the total number of committees you can make without any constraints. So since there are 10 people here, the total number of committees you can make is 10C3. And committees with all men will be when you are selecting 3 men out of 6. So if you subtract 6C3 from 10C3, you'll get the same answer as you would get on this side. And you can check that. An interesting note here is to understand from this question, you need to understand this, that from 10 people, if I want to draw a committee of 3, the number of committees is 10C3. That's fine. But if I divide these 10 people into 6 men and 4 women, and then I tell you that you have to make committees of 3, and I don't give you any constraints. So in case you decide to do this problem using how many men and how many women you are doing, and you write the comprehensive list of all the committees possible, so you will say committees with 3 men and 0 women, or 2 men and 1 woman, or 1 man and 2 women, or 0 men and 3 women. So what you will see in this scenario, if you list all the committees, the committee listing will also be 6C3 into 4C0, but there are 4C0 in into form you don't need to write. So even though you visualize it, you actually should not write it. Plus, because it's 4C, NC0 is always 1, plus 6C2 into 4C1 plus 6C1 into 4C2 plus 4C3. So this is, you will see if you calculate this 10C3 and you calculate this, you will get the same values. The value of 10C3 is 1098 upon 321. So you can see this, that this is 3 and this is 5. So the value of 10C3 is 120. And if you check all this, you will again see that the value of this will also be 120. So hence, if a question is giving you a constraint of only counting this, you always have the subtraction of 6C3 from 10C3 as a possibility, because you are in a situation where a total is equal to 4 parts. A total is equal to 4 parts. So if you want to calculate only the sum of 3 parts, you can subtract this part from the total and get the answer. So this is always available, and for all these questions you can always do it by subtracting from the total or adding independently. And I want you to try those in the assignment which follows this lesson. And last but not least, another question where the same thing applies. We had done the triangles, quadrilaterals and straight lines questions a little bit earlier. So suppose I tell you that there's a plane on which there are 12 points, all of which are non-collinear, 12 points on a plane, all of which are non-collinear, except 5 points that lie on the same line. So in this case, how many triangles, how many quadrilaterals, and how many straight lines can you make? So this question, you might not be able to see it right now, but this question is exactly the same as the men-women question that we did a little bit earlier. So what you have to do here is you segregate the points into the 5 collinear points. So what this question is saying is that there is a straight line on which these 5 points lie. And apart from that, all the other points in this plane are non-collinear. That means no other 3 points lie on the same line. Non-collinearity basically means that. So in this scenario, if you have 5 people or 5 points which are on the straight line, and you think of 7 points, F, G, H, I, J, K, L, which are the non-collinear points. These are the collinear points. So all these 3 questions, the triangles question first, all these 3 questions you have an option of doing through excuse me, all these 3 questions you have an option of doing through either adding cases or subtracting cases from the global situation. So as you know, for making a triangle you need to select 3 points. So 3 points, if I am visualizing 3 points, I can think of, first of all, let me think unhindered, unencumbered. So when I think that way, selecting 3 points can happen 2, 3, 0 or 2, 1 or 1 and 2 or 0 and 3. So in this scenario, if you take 3 points from this line, obviously you are not forming triangles. So this is not going to form triangles, but if you take 2 points from this line and 1 point from outside, you can definitely see that triangle will get formed. So 2, 1 will form triangles, 1, 2 will form triangles, and if I take 3 points from outside the straight line, that would also form triangles. Hence, the number of triangles in this case would be 5C2 into 7C1 plus 5C1 into 7C2 plus 5C0 into 7C3. And the parallel scenario, if you want to do this from subtraction, then the sample space of selecting all the cases, not sample space, but selecting all 3 points from 12 would be 12C3. And because 12C3 will be equal to the sum of all these 4 cases, and if I want to count only 3 of them, then I can also do this with 12C3 minus 5C3. So in the same way, I will just write the solutions, and I think you can make out for the quadrilateral, the solution will be, if I take 4 points from here and 4 points from here, it won't work. If I take 3 points from here, it won't work, because 3 points from the straight line and 1 from outside does not form a quadrilateral. So for the quadrilateral, the selections are 2 and 2, 3 and 1, or 4 and 0, or maybe I should write it as 2 and 2, 1 and 3, and 0 and 4, depending on whether you're taking it from the 5 collinear points or the 7 non-collinear points. So the answer for the quadrilateral will be 5C2 into 7C2 plus 5C1 into 7C3 plus 5C0 into 7C4. And you can also do this by subtracting from 12C4 these 2 cases when you are selecting 4 points from the straight line and 0 from outside, and 3 points from the straight line and 0 and 1 from outside. You'll have to subtract these 2. So the answer would be 5C4 minus 5C3 into 7C1. But as you can see, there's no fun or no advantage in doing this, and there's always a chance of making errors in this. So always use this addition approach, because in that case you can actually see each of the solutions. And in the same question, when you want to do straight lines, what will happen is you have this straight line A, B, C, D, E. So this one straight line has to be counted in separately, and then you have 5 collinear points and 7 non-collinear points. So you can form straight lines by selecting 1 and 1, or you can form straight lines by selecting 0 and 2. So the number of straight lines will be 5C1 into 7C1 plus 5C0 into 7C2, and again you don't need to write the 5C0. You should avoid writing NC0 in any situation where it's used as a multiplier to some number. And to this is not the answer. To this you will have to add 1, because this line, when you select any 2 points from this, you'll form the same line, whether you're selecting AB or you're selecting DE. The line, which is the infinite line on both sides, will be the same, and hence that line, the ABCD line, has not get counted when you selected 1 from here and 1 from outside, or when you selected 2 from outside and made a line. So this line has not been counted, so you'll have to add a +1 to that to get the answer. So I hope you enjoyed this lesson, and I hope you have learned out of this. So selections, as I said, is the crux of this chapter. Once you get selections in place, distributions and arrangements are going to be simple for you, and we'll come to those as we move on to the next lesson. Bye for now. Thank you.